Hello, my name is Steve Coble. I'm with the RAC Precision Signal LLC Corporation. I'd like to talk to you today about the red dot alignment procedure for field aligning of your highway flasher lights. Before I get started into the red dot system, I'd like to have a brief review of the highway flasher light itself. We got a typical unit right here. We have a red outer lens. This outer lens has a 30-degree spread, both left and right. It also has a 15-degree spread down. On the inside, in this unit, we got an incandescent bulb and we have a back reflectant lens. Now, the new flasher lights coming out, they're LEDs. I've got one of those down there. They're a little bit different. On the inside, there's nothing. It's blank, no reflectant lens, no anything. What these are, you have a bunch of LED lights. Basically, your outer lens is a bunch of LED lights. Now, right in the center of the lens, you have quite a mass of LED lights. So what you've got, you have a hot spot right in the center of your LED lights. The red dot alignment scope works very well for pinpointing or precisely aligning that hot spot exactly where you want it to be. The red dot alignment scope is an excellent tool for aligning your LED lights. Okay, back to this unit right here. Now, how this works, when the bulb lights up, the back reflectant lens will put out a floodlight beam of light. Then when your lens closes, your outer lens will spread that light 30 degrees both ways and also 15 degrees down. Now, for any reason, and it's usually vandalism, somebody shot your lenses out, busted them out, or someone knocked your bulb alignment out of adjustment. You've lost that factory adjustment. You lost that good beam of light. The only thing I can tell you what to do is you need to change the whole unit out with a good used one or a brand new one. Because with the incandescent light, you need that good beam of light to get a good light for this type of unit. That's the basics of your highway flasher lights. Really, they're all pretty much a pretty simple light. Let's move on to the red dot system. Here's the red dot kit. It comes in a nice carrying case. It's heavy duty plastic, it's waterproof, and it's all foam lined. Inside the kit, we have the red dot alignment scope. Basically how the red dot alignment scope works, you install it into your unit, and we'll get into that in a little bit. Then you turn the scope on. The scope has 11 settings, and there's a knob right here. You turn it on, like I said, it's 11 settings, 11 being the brightest, 1 being the dimmest. 0 is off. When you're finished with your alignment procedure, you want to make sure you turn your scope to 0 or off, or the next time you use it, your battery will be dead. Okay, basically, like I said, you put it in the unit, turn your scope on. You look right through the scope, and with it turned on, there's a red dot in there. That red dot is aligned right with, or exactly with, the hot spot of the LED lights and also the center of your floodlight beam. Basically wherever the red dot is aligned to, your flasher lights are aligned to. So really all you have to do is line your red dot down the roadway, out the distance, and the height that your railroad specifies. And by having this scope and using the scope, it eliminates the need for the second employee down the roadway, standing in the middle of the road with his back to the traffic, giving hand signals or with a portable radio, telling the guy up at the flasher unit to take it up, take it down, take it left, take it right. You no longer need that. That's eliminated. Also, when you use the alignment scope, you don't have to have the lights on. You don't have to have them flashing. The only time you need to turn the lights on is when you're finished with your alignment procedure. You need to go back and look at your lights and verify that the alignment is correct. Okay, that's basically how the red dot alignment scope works. Okay, let's get into how we mount it into the signal unit. This design is a universal fit. In other words, it will fit most of all the flasher units out there, made by all the different companies. It fits different sizes. It fits the 12-inch units and the 8-inch units. And how it's able to do that is that on your flasher housings, we have this curve right in the housing, this arc or this curve. And what we're doing, that arc or that curve will fit right on top. Well, your sighting device has two guide pins right in the sighting device. The curve of your flasher units will set right on the top of these guide pins. Then you adjust these thumb screws, which tightens against your flasher housing and holds it in place. That's how it's installed. Now, another nice feature with this sighting device, the scope. You're able to swivel or swing this scope from this side to this side. And here's how you do it. There's a knob right here. You simply push in and turn it a quarter of a turn, and now the scope will swivel to the other side. Push in and it locks in place. I like this feature because when you're at the flasher site, you can always have the scope on the outside of the flasher lens. And by the outside, I mean if this was an actual location, right here would be your pole, and this side of your flasher unit's your inside, and this would be your outside. By the scope always being on the outside, it's a lot easier and more comfortable to see through the scope. It works a lot better when the scope's always on the outside. Okay, to mount the unit, the first thing was just go through step by step. You come to your unit, you decide which side you want the scope to be on. You want it on the outside. In this case, we want it on this side. So you swing your scope over. Okay, you open your flasher lens. Now, on your sighting device, we have a positioning bolt. It's on your flasher unit right here. It's screwed right into the housing. It's there just for a position for storage. You remove it, and that positioning bolt right on the tip on the end of it, it's got a pin through it, and it's T-shaped. You want to install that into your flasher unit. Okay, you want this T up and down, perpendicular. You take your sighting device, and through that slot right here, that will slide right onto your positioning bolt. Now, after you put it on the bolt, you want to turn that bolt horizontal. Because if you leave it up and down, the scope is balanced, or although there's a little more weight in front, and it's counterbalanced that if it would slip out of your hands, it would roll right off that positioning bolt. It would slip right off and hit the ground. If you put it on and turn that positioning bolt horizontal, if it would slip out of your hand now, the T of the position bolt would catch it. So make sure you turn it horizontal. Now also, when you put this on, you want to make sure that your sighting device is flush against the housing. You want to make sure it's tight. You don't want any gaps between your housing and your scope. Make sure it's tight. So you install it on your position bolt, turn it horizontal. Now don't be afraid to use some pressure. Push against that thing tight, push in and push up. And like I said, you can use some pressure, make sure it's tight. Now what you do is you take your thumb screws and just tighten this one just so it hits the housing. Now you come on this side, you tighten it just so it hits the housing. Alright, now you just basically go snug, snug evenly, and just snug, snug. You don't want to over tighten these thumb screws. Basically, I just like to go snug, 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 snug. That's sufficient. Okay, it's mounted in your flasher housing. You basically look through the scope and you line it down the roadway, out the distance, and the distance out and the footage up from the pavement that your railroad specifies. On the railroad where I worked and where I retired from, that distance out was on your front lights was 400 feet out and 5.5 feet up on the pavement. What I would do is I had a traffic cone, an orange traffic cone. I would take it down the roadway, right along the edge of the road. I would set the cone out 400 feet. And that, like I said, that cone was 3 foot tall. I'd come back to the sighting device. I would put the red dot approximately 2.5 feet above the cone. Then I would tighten my up and down tightening bolt. I'd tighten it. After that was tight, I'd simply swing the red dot right over into the center of the road. Now if it was a very busy highway, I would just put it right on the windshields of the incoming traffic. Tighten it. Your signal unit is adjusted or aligned. Now, on your backup lights, and I want to get into this, on your backup lights, that footage out on the railroad where I used to work was 50 to 100 feet. And what you're going to run into at that short a distance, you're going to think that this scope is out of adjustment. It's not. Here's what's going on. The scope is adjusted for the farther out distance. It's dead on at the farther out distances. What's happening at the shorter distance, say at 50 feet, we have the center of our hotspot of our LEDs or the center of our floodlight beam right here. Our scope is up here at basically the 10 o'clock position. It's 6 inches this way, approximately 6 inches and 6 inches up. If I can explain it better, if I was standing in the center of the road 50 feet out and the floodlight beam was hitting me right here, the red dot would be approximately right here. What you're going to need to do when you adjust it, just compensate for that distance here and here. Now if the scope was on this side, the floodlight beam would be here, the red dot would be here. When you make your adjustment, just compensate for this little bit of a difference. After you do a couple of these, you're going to see exactly what I'm talking about. And you'll catch on to it pretty quick, but that's how you want to adjust this for the shorter distances. Okay, after your flasher light's all adjusted, you want to remove your sighting scope. Loosen your thumb screws. Remove your sighting device. Make sure you turn your scope to 0, which is off. Close your flasher lens, tighten it, and that signal is aligned. That's pretty much everything I wanted to cover with this. I hope this DVD gives you a little bit better understanding of how the red dot alignment system works and how to use it in the field. I want to thank you for your time and have a good day.